Welcome to 7.7 Introduction to FRATEY. Now that you have seen the overall process for FRATEY, let's go ahead and start applying it to problems. So example 1 is x minus 2 over x plus 4. And this is already in factored form, so I'm just going to rewrite it for my f factor. R stands for roots, so I'm going to take my numerator, set it equal to 0 to get my x-intercept. So I get x minus 2 is equal to 0, x is equal to 2. Remember that we write these as coordinate points, so this should be 2, 0. A stands for asymptotes, which are our vertical asymptotes. So I'm going to take my denominator, set it equal to 0. I get a vertical line at x is equal to -4. And if you notice, as I am going through the steps of FRATEY, I'm adding on the pieces that I know to my graph. T stands for twins, meaning I'm looking in the numerator to see if I have two of the same factor, and in the denominator to see if I have two of the same factor, which in this case I do not. So I always include a statement that says no twins, therefore no tangency, no togetherness. E is in behavior, or our horizontal asymptotes. Now I am going to be looking at the coefficients with the highest power. So here I have x to the power of 1, x to the power of 1. And since these are the same, we are in that eats DC category. Exponents are the same, divide the coefficients. Well, when I just have x by itself, it's a coefficient of 1 over a coefficient of 1. So my horizontal asymptote is going to be at y equals 1. For my y-intercept, I am going to plug in 0 everywhere that I see x in my equation. So 0 minus 2 over 0 plus 4 is equal to -2 over 4, which simplifies to -1/2. So my y-intercept is at 0, -1/2. Now, before we go on and actually draw our curves, there are a couple of things I want to talk about with FRATEY. Sometimes it is better to work in factored form. Sometimes it's better to work in standard form. So here is standard form, and here is factored form. So when you're getting your roots, you want to work in factored form because you'll have to set your numerator equal to 0. When you're getting your asymptotes, factored form. Twins, you want factored form. End behavior is best in standard form, and y-intercept is best in standard form. So just know that going forward. Now, as I look to start graphing my curves, you have to think of your graph as vertical chunks. So I have one vertical chunk here, split by my vertical asymptote, and another vertical chunk here. Each vertical piece has to have one curve, either in the top or in the bottom. It cannot be both. So I need to either place a curve up here or down here. You also have to remember that we cannot cross a x-axis or a y-axis unless we have an intercept there. So the first thing I notice about my first vertical section is I have one piece that's above the y-axis and one piece that's below. Well, in order for my curve to fit below in this bottom section, I would have to have some type of y-intercept here for it to cross over, a gateway. Since I do not have that, the only placement for my curve is going to be up top. And now I'm going to move on to my second vertical piece. Now remember, we are separated by this vertical asymptote. Since I do not have any togetherness at this vertical asymptote, I know that my curve has to start down here. It has to. They're not coming together. That means they're going in opposite directions. Well, I'm going to come up from here, go through my y-intercept, through my x-intercept, and come up to my end behavior horizontal asymptote. Now, if you were unsure of your placement, you could think about, well, what would happen if I put it up here? Well, first, I don't have togetherness, so that wouldn't work. Second, I don't have a y-intercept here for my curve to pass through. So because of that, the only placement it could be is down here in this lower quadrant. So let's go ahead and look at example 2. First thing I'm going to do is I'm going to factor my numerator and my denominator. So I notice that in my denominator, I'm going to have to split the middle because of the fact that a does not currently equal to 1. So I'm going to go ahead and do that rather quickly. So I need something that multiplies to be -6, adds to be -1. Those two factors end up being +2 and -3. I split my middle, grouped my first two, pulled out a 2x, grouped my second two, pulled out a -3. When I factor, x squared minus 4 becomes x plus 2, x minus 2, and the denominator is 2x minus 3, x plus 1. Now let's go ahead and look at our roots. Remember, I'm going to set my numerator equal to 0, so that's going to produce two roots this time, -2, 0, +2, 0. For vertical asymptotes, I'm going to set my denominators equal to 0. That's going to give me 2. X equals 3 over 2, which is 1 and 1 half, and x is equal to -1. Again, I'm not dealing with any twins or tangency. Yes, these two almost look alike, but they are different because one is positive, one is negative. Not twins. We want identical twins for t. In behavior is going to look at our highest exponent. And since the numerator and the denominator both have an exponent of 2, all I'm going to do is the eats dc, divide my coefficients, 1 over 2. My end behavior is going to be y equals 1 half. Now notice that I did not draw my horizontal asymptote in the middle. You can do that, but sometimes it does confuse you if you do happen to have to pass through it. Remember, E stands for end behavior. So it's really going to focus on what's happening in these end vertical pieces. For y, I'm going to plug in 0 everywhere that I see an x. That gives me -4 over -3, which is +4 over 3. So my y-intercept is at 1 and 1/3. Now that I have all of my pieces in place, again, you want to be mindful of the fact that I can only cross an x-axis and a y-axis where I have intercepts. Then we move on to actually drawing our curves. So unlike my first example, I have one vertical piece, two vertical pieces, three vertical pieces. So I should have three curves on my final graph. So again, you have to go through the intercepts, and you can only cross your axes where there is an intercept. So since there is an intercept here in this lower section, I'm going to go ahead and draw my curve so that it goes through that intercept, comes down to my vertical asymptote, and still is going out to my end behavior. Now, again, we do not have any tangency or togetherness. So I'm going to go ahead and assume, since my curve is going down in this direction and I don't have any togetherness, this means my other piece has to start up here. So it's going to start up here and it's going to come down. And for now, I'm going to leave it at that because I don't necessarily know what's going to happen on this side just yet. Similar to what we did over here, I do have an x-intercept, so I know that I need to go through that. I'm going to come close to this vertical asymptote, go through my x-intercept, come out to my end behavior. And since I don't have any togetherness at this vertical asymptote either, I'm going to draw my curve so that it's going up in the other direction. Let's go ahead and look at example 3. So my first step is to factor. So I have a GCF up top that becomes x times x plus 2. And when I factor the denominator, I can use the shortcut to get x plus 3, x minus 6. My roots tell me to set my numerator equal to 0. That's going to produce a root at 0, 0, and a root at -2, 0. My asymptotes tell me to set my denominator equal to 0. So that's going to give me a vertical asymptote at x equals -3 and x equals +6. I do not have any twins, so I have no tangency and no togetherness. All of my curves should be going in opposite directions at the vertical asymptotes. In behavior, if I look at my highest exponent, I have a 2 and a 2. And so I'm going to divide the coefficients, which in this case is 1 over 1. So my horizontal asymptote, my in behavior, is at y equals 1. Again, I did not draw it in the middle. You are welcome to. Just remember, it is something that we can cross, unlike our vertical asymptotes. For my y-intercept, I just plugged in 0 everywhere that I saw an x into my original problem. That gave me 0 over -18, which produces a y-intercept of 0, 0, which I currently have already there from my x-intercepts. So now let's go ahead and get drawing on our curves. So again, if it helps highlight your x-axis and your y-axis, remember that you cannot cross them unless you have a intercept there. So I'm going to look at each vertical section. Here I have 1, 2, 3, meaning I should have 3 curves in my final graph. So I'm going to focus on this first section. I have the option to put it up top or put it down below. The issue with down below is I would have to have some type of intercept to cross over here. I do not have that, so my only option is to go up top. And when I get to my middle section, I have to remember I do not have togetherness. So I'm going to start down here, go up to my x-axis, my x-intercept. I'm going to go up above it because it's like a gateway I can pass through now. Well, the only y-intercept I have is back here. So I need to come back around, kind of do a U-turn, go through my second x-intercept and my y-intercept, and I'm going to come back down. Now, if I were to extend this graph further and further, this end behavior in terms of y is going to keep going down and down and get closer to this vertical asymptote. And so if I'm ending here, I know I do not have togetherness, so my other piece must start up here. Draw my curve. Want it to have in behavior of y equals 1, and that is our graph for example 3. Now, example 4, we are going to approach in the same way. I'm going to factor first. My factors end up being, if I go ahead and split the middle, I have to multiply to be -12, add to be +1. That becomes -3 and +4. I get 3x plus 4, x minus 1. X times 2x minus 5. You have to be very quick with your factoring now. It's just a small part of the big problem. So now I'm going to set my numerator equal to 0. That gives me 2 x-intercepts, one at -1 and 1/3 and one at +1. I'm going to have 2 vertical asymptotes, one at x equals 0 and one at 2x minus 5 equals 0, which is x equals 5/2. T, again, we're not dealing with tangency or togetherness today, so I have no twins, no tangency, no togetherness. In behavior, I'm going to look at my highest exponent. Both of them are 2. Yes, that will eventually change, but for now on day 1, we're going to make sure that we're doing something consistent. So I'm going to take my coefficients 3 over 2. That's going to become the in behavior for my curves. For my y-intercept, I'm going to go ahead and plug in 0 everywhere I see an x in my original problem. So that gives me -4 over 0, which ends up being undefined because remember, we cannot divide by 0. So there's no y-intercept for this problem, which really makes sense because I have a vertical asymptote on my y-axis, meaning I absolutely cannot cross that line. So because of that, I don't have a y-intercept. So I'm just going to highlight my x-axis for this problem because we're really not even dealing with the y-axis in any way. You should not be crossing it whatsoever. Again, I do have one vertical section, two vertical sections, three vertical sections. So I should have three curves. And I notice in my first section that I have a x-intercept already. So I'm going to go ahead and draw that piece where it fits. Now I'm going to go ahead and look at my middle section. So I know I don't have any togetherness, so I'm going to start up top, go through my x-intercept, and I don't have any tangency, so I can't come back this way. So instead, I have to keep going. And it is okay to have a curve that looks like this. We call this our S curve, kind of a backwards S in this instance. Now, I don't have any togetherness at this last vertical asymptote, so I know I need to start up top, come down, go out to my end behavior of, 3/2, 1 and 1/2. There is my final graph. Now let's go ahead and look at our last kind of critical thinking problem. We're going to create a rational function that has roots at -4, 0, and 4, 0, has a horizontal asymptote at y=3, and a vertical asymptote at x=3, x=0. Well, roots are the R part of FRATEY, horizontal asymptotes are the E, and vertical asymptotes are the A. So we're going to kind of work backwards, and what you can do for this problem is we're going to leave it in factored form. We're not going to multiply it out, leave it in factored form, save yourself some trouble. So when I have roots -4, 0, and 4, 0, they are coming from our numerator. So I'm going to create two factors, x + 4 = 0, x - 4 = 0. The next easiest thing to tackle is the vertical asymptotes. So these vertical asymptotes are coming from the denominator being set equal to 0. So I have x = 0 and x - 3 is equal to 0. My factors that I need to be considering, let's highlight what's important, x - 3 and x. And then end behavior is going to be important because it's going to relate to the coefficients of the highest exponent. If you end up with a value, which we have so far, we're going to be just dealing with the coefficients. So first thing I'm going to do is create an equation. Y equals, I'm going to have my fraction bar. Seems everything kind of come out in pieces. So I'm going to kind of just click until everything appears. I put my two roots, x + 4, x - 4 up top. I put my two asymptotes, x and x - 3 in the bottom. And I treated y = 3 as y = 3 over 1. So I just put those coefficients in front because it already ends up being an x squared value when I multiply these out and an x squared value when I multiply these out. You could also get a little creative. Maybe instead of 3 over 1, you used 9 over 3. That is fine as long as it still simplifies to be y = 3 as the end behavior.